Good morning, we're on to lesson 5 notes. Yesterday we talked about how to solve logarithmic equations. So any equations, anything with equal sign that has logs involved with it. Now we're going to go through how we can use logarithms to solve exponential equations. So this kind of goes back to what we were doing in the last unit. So remember there are 3 main ways to solve exponential equations. We talked about using common bases in unit 5. That's probably one of the quickest ways to do it, but it won't always work because you can't always have common bases set up so perfectly. We also did it by solving by graphing in unit 5, where you graphed each side of the equation, the left-hand side and the right-hand side, and you saw where they intersect in your calculator. And you can also solve exponential equations that way. And then we left the using logarithms way till now, because now you have a good knowledge of logarithms. But we can also use logs to solve exponential equations. And this will work for everything. So if you don't have a graphing calculator to graph it and find the point of intersection, or don't want to draw it all out, you can always use logarithms as well. So let's look at some examples here. So again, here's some exponential equations where our variable is in the exponent. So now what we can do is solve for x using logarithms around ground to the nearest tenth. When you want to solve using logarithms, what you need to do is take the logarithm of each side. As long as you're doing the same thing to each side, and then you're not changing the equation. So I'm going to rewrite this like this. And I just take the log of both sides, log base 10, the regular one that's the button on your calculator. Now we know our log rules, so I can rewrite this one here. Instead of having that x as the exponent, I can pop that in the front. And now I can solve for x by dividing both sides by log 2. And now it gives me a chance to isolate the x. Before we knew about logarithms, you weren't ever able to isolate the x because it's in that exponent spot. It's really hard to get it off on its own. But when you take logarithms of both sides, that allows you to isolate the x on one side, so you can actually solve it. Now you just have to type this part into your calculator. You're just going to hit the log button, log 5, and divide it by log 2. So I'll show you here. So you're going to hit log 5, close your bracket, and divide it by log 2. And now we found out that our x must equal approximately 2.3. So logs are pretty handy for solving exponential equations. So we can do the same thing with the one on the other side here. What I like to do is isolate the expression with the exponent first. A common mistake I see here is people rewriting this as this. That is incorrect. I will make a big unhappy face, I guess, on the computer screen for you if you do that. The 3 is under the power of that exponent x, not the 2. So you cannot combine those 2 together. That is impossible to do, not mathematically correct. What you can do is divide both sides by 2. Like that. That is okay. You can never combine those 2 and 3 together unless they had the same exponent. Okay, so now we can take the log of both sides in order to give us a chance to isolate that x. Now using your log rules, you can pop that x in the front. Okay, and now I'm going to divide both sides by log 3 to get x by itself. Now you can use the log button on your calculator to just type it in, and you should see x will equal approximately 1.8. You can test it out as well. If you go back into here and substitute in that 1.8 there, you should get approximately 15 when you type it in your calculator. We rounded, so it might be slightly off, but it should be very close. So you can always check your answer that way. Okay, so there's more here. Solve for x using logarithms. I'm just going to go through maybe a couple more of these. They get a little more complex when you have more variables in the exponent spot. So let's look at this one here. It's not going to help me at all to divide both sides by 2 because I have unknown x's on both sides. So what I'm going to do is still take the log of both sides. still going to use my exponent rules, but now I'm going to have to split this up and expand using logarithms to break it up a little bit. So this expression here, you can break up. This is like it's being multiplied 2 times 3 to the x. So let's give them each their own logs. Remember, when you're multiplying, if you want to expand it out, you're kind of working backwards. You can change it to adding and give them each their own logs. Okay, now that I have the x and the exponent here, now they're all in logs, I can pop that x in the front. Okay, so you can see this one's a little bit more complex because I have an x in 2 different spots now. So what you want to do is group all the terms with x together. Onto one side. So what I did here is I minus x log 3 from both sides. Now we want to isolate a single x. It's hard because there's several here. We're just going to ignore this guy for now. So what you're going to have to do is you can factor out an x from the right-hand side of the equation here, right? There's like a greatest common factor. There's an x present in both. So I can factor out an x from both of these, and what I'm left with is a log 4 minus a log 3. I've divided out an x from both of those terms there. Now you can isolate the x by dividing both sides by log 4 minus log 3. And now we have our x for ourselves. So you have to be careful. If it's just a single x, it's not too bad. It's pretty efficient to use logs, so you can do it really quickly. If you have more x's, like we had up here, you ended up having an x here and here, you're probably going to have to expand it all out and then factor out the x to get it to be a single x to isolate. And then you're going to type that into your calculator. So again, just be careful with brackets. So I have log 2. Make sure you close this bracket, otherwise you're taking the log of absolutely everything in there. So I have a log 2, and I'm going to divide it by, open a bracket again, log 4 minus log 3. So I do recommend try typing that in after with me and make sure you get the same answer as me, but you should get 2.41 when you round it to the nearest hundredth. And that one is done. The other ones are done similarly, but I will do this guy here. So again, same thing. You see you have an x on both sides there. So immediately just take the log of both sides. Okay, so now what we can do is we can split up the logs. So again, this is like you're multiplying right there. So I have a log base 2 plus log 18 to the x. And on this side here, I just have a log. I'm just going to kind of keep it the same. Then all those exponents, once you have it all in logarithmic form, you can pop those exponents in the front. I'm going to put brackets around this one. Make sure you do put brackets around this one when you pop it in the front, because this whole thing is kind of a unit. It has to move as a unit to the front of your logarithm. And now, like we said before, we want all the x terms to be together. But what you can see is this works the same way with our same mathematical rules to get rid of the brackets. All I have to do is multiply this log 6 to both of these to get rid of those brackets. So that's what I'm going to do next. You can see how complex the examples can get. As long as you have the basic understanding kind of from the above examples, you're probably good to go, but it doesn't hurt to have a lot of extra practice here. So when I multiply log 6 to x, it's going to be x log 6. And then 1 times log 6 is just a log 6. Now you're going to group all your logs with their x's together. So I'm going to have an x log 18. And I'm going to minus off an x log 6 from both sides. I'm moving this guy over here. Now I'm going to move the log 2 over here. So I'm going to minus log 2 from both sides. Now I have all my terms with x's on one side of the equation and everything else kind of lumped on the other side. Now you can see we can factor out an x from the left-hand side. So divide an x out of both terms. And now finally you can isolate that x by dividing both sides. So maybe I'll write that over here. Hopefully it's nice and clear in your notes. So I'm going to have a log 6 minus log 2, and I'm going to divide off the log 18 minus log 6. Then you have to type that thing in your calculator. Make sure you put brackets around this so that it divides properly. I'll show you how to type it in. Definitely practice with me, make sure you got it. So we have a log 6 minus log 2. Close those brackets. And I'm going to divide it by log 18 minus log 6. And close that final bracket. And you should get a nice easy peasy number of 1. So x just equals 1 after all of that. That's your solution. And again, don't forget you can type that back in up here and just put in a 1 for your x and make sure each side equals the other, and then you know you've done it correctly. Okay, so that's essentially it, but I kind of want to put the knowledge all together. So here I have solved the following exponential equation using all 3 methods. So remember, there's 3 different ways you can approach this thing. We could solve it by common bases. We could solve it by graphing in our calculator. And now you know how to solve it by using logs. And you should get the same answer for each of those if you did it properly. So let's do a refresher of each of those, and then I'm just going to pop down with a little summary, and that'll be it for today. So for method 1, common basis, with this equation here, looking at it, I can see that 2 is going to be a nice common base. So I'm going to rewrite this as 2 times 2 squared x. I just changed the 4 to a 2 squared. And 32 is the same as 2 to the 5th. I actually did it a different way in your notes, which might have been a bit easier. If you notice in the notes, even quicker, you can divide both sides by 2, and it makes it a lot easier for you. Or you could do it this way. Let's see if it works the same as my notes. Okay, so now we have this. They're multiplied, so you can add your exponents to make it the same base. If this matches this, then you know the exponent has to match the other exponent. I'm going to minus 1 from each side. And then I'm going to divide both sides by 2, which gives me a final answer of x equals 2. So you can do it this way, or if you look in the notes, I simplified it a bit by dividing both sides by 2 first, which is totally okay. You'll still get x equals 2 as your final answer. Solving by graphing, that was the second method in our last unit. That means you take the left-hand side of your equation and enter it in as your y1. Then you take the right-hand side of the equation and enter it in as your y2, and you find the point of intersection. So let's do that quick. Let me just clear all this out. Okay, so for my y1, I have 2, and then in brackets 4 to the x. And for my next one, I have a 32. Since my y value for that second one is 32, I know that on my window, my y is going to have to go up to 32 for sure. So let's change this to a 50 and my scale to a 10. Oh, these are changed from before. So max 10, min negative 10. I'm going to graph it. And now you can see where they intersect. So you're going to go into your calc button, go down to intersect, the 5th one down. And then you're just going to hit enter for your first curve, second curve, and then you're going to take a guess, move that cursor over to about where they intersect. And I can see their point of intersection is at 232. And then your x value of your intersection is your solution. You know we did it right because it matches the first one. Next, we can take the log of both sides. Okay, so this is method 3. What I'm going to do first is I'm going to divide both sides by 2 just to make it a little bit simpler right off the bat. So I divided both sides by 2. Now I'm going to take the log of both sides. Now my x can pop in the front based on my logarithm rules. And then I can divide both sides by log 4 to get my x by itself. And then all you have to do is go in your calculator and type in log 16 divided by log 4, and you'll see x equals 2. So now you have 3 different methods you can use for solving exponential equations. I'm going to skip the word problem, maybe have a look through, make sure you remember how to set it up. And I solved it by logarithms, so you can see I have that method. This is super important. Change of base law, it makes your life so much easier. And I'm going to show you what this means and what you can do with it. So it says evaluate log base 5 of 782 and round to the nearest hundredth. Okay, so I'm going to show you the long way, the way we're used to right now to solve this. What I would do is I would change this into an exponential equation. I want to know what it equals. What does this equal? We call that x. I want to figure out what x equals. So my long way is changing it into exponential form. Now I can take the log of both sides to solve it, or use one of the methods above. The x can now pop in front. And now to isolate x, I can divide both sides by log 5. When I type that in my calculator, I see that x equals approximately 4.14. That's a long way to do it. There is a shortcut. This can simplify into this rule here. What we can do is if we're trying to find a log that's not base 10, if it's base 10, you can just punch it right into your calculator and figure it out. But let's say I want to find log base 5 of 782. It will always equal log 782 over log 5. So the log of this number here divided by the log of this number here. We used to do this by hand the whole time, but now here's the shortcut you can use, and I believe that's on your formula sheet as well. To figure this out without having to do all this fun work, you can just take the log of that bigger number, well, the main number there, divided by the base. And when you do that, you'll get 4.14. So to put that in perspective, when we used to do this here, you would do it in your head or kind of trial and error, and you'd think, okay, 5 to what exponent gives you 625, and you'd plunk away until you could find it, or you'd use common basis to find it. Now you can use this shortcut and know it's just log of 625 divided by log 5. So you can actually go and check over your answers if you're doing it by hand to figure it out. And you'll see this equals 4. What we used to do is we'd think 5 to some exponent equals this, and we try it out in our calculator until we got it. Same thing with this guy here. Instead of trying to plunk away in our calculator and use common basis to try and figure it out, you can now evaluate it. It's just going to be log 5 divided by log 625. So that's a super important rule that we learned there. Nice way to check your answers. You'll see your answer here is a quarter. You can do it way quicker than the old way, which would have been this, and writing it as common bases, which this would become 5 to the 4x. And then this matches this, so 4x equals 1, divide both sides by 4. You can still do it this way if you like, but if you're a little tricky, especially with fractions, if it's really complex, now you have a new rule to work with. I hope you have a wonderful rest of your day.